Martin Lord. I'm with Ontario Centre of Innovation. I'm happy to be one of the partners of Newport and Canadian Tire on their project there. And so we're happy to be able to support that and to lubricate that relationship. So my here piece is about AVIN. AVIN stands for Autonomous Vehicle Innovation Network. And let me give you some background of that. So why really AVIN came about is really out of the province of Ontario's general advantage in the world of automotive historically, with 5 OEMs being involved, being basically a second manufacturer after Michigan, and then having a whole range of companies supplying to those OEMs, which we call original equipment manufacturers, and as well as having the second largest ICT cluster after Silicon Valley, really. So AVIN was created by the province of Ontario, Ministry of Economic Development, Job Creation and Trade, Ministry of Transportation, and to really pick up where the province is and really help grow the entire cluster. And so combine the two automotive and ICT clusters and take us away on the future of mobility. Now, AVIN, although its name implies autonomous vehicle, but we do way more than autonomous vehicle. So we got some of the numbers here on the side. So some co-investment secured. We're measured by key performance indicators. The province basically is hiring Ontario Centre of Innovation, so we can deploy this initiative on their behalf. And basically, we've got funds available. We have a network of support, and we collect those metrics across the network over the years to be able to show what our results are. So just, I guess, an example, we've had the R&D job placement. We support hiring of folks. We've helped create or retain 1,365 jobs, commercialization partnerships, supported 245 SMEs, and follow-on invested generation of 89 million. So that's in short. Now, what I was telling you earlier was about the right ingredients here that you show on this picture on the southern Ontario side. So the red ellipse shows you where the manufacturers, the automotive manufacturers are. So the main 5 ones, and we have a number of what we call tier 1s and tier 2s as well. And then on the blue ellipse, you see from Ottawa to Waterloo, basically what is considered the so-called ICT or tech corridor. So here I wanted to talk, and I mean, everyone must be familiar with that. So we talk about the CAS, C for connected, A for autonomous, S for shared. Here is represented by multimodal and integrated mobility, which is often what we refer to, shared like e-bikes and e-scooters and your ride-sharing kind of software, the Ubers, etc. And then zero emission, or what we call the E for electrification. So those are really the main 4 trends and technologies that we see today in the future of mobility. So autonomous vehicles, well, everything that basically Raghavendra talked about earlier, well, that's part of what is being included in that section. Then the connected vehicle, typically you will see anything that's connecting a vehicle to the internet is for infotainment, for direction finding, for navigation. That's all part of the normal thing. And you know that you can actually, I was demonstrated years ago on a Jeep where you had some hackers who managed to control the vehicle through getting into the infotainment system. So that's a well-publicized piece. But what's important as well is what we call the V2X. V2X here, vehicle to everything, meaning infrastructure, other vehicle, pedestrians, whatever else. So that's a communication system that's regulated and that's defined with standards. And that allows really a controlled and communications between vehicles, mainly for safety reasons. And then the multimodal integrated mobility. So as I mentioned, it's all basically what's considered shared. Emission vehicle, zero emission, for now, we're not really so much into this, but please wait for a moment. Now, we all talk about all of this, how excited it is, how exciting it is, but have you ever seen this video, guys?
And now we see an enlarged section of
1939.
motorway. Along the ledge of this beautiful precipice, traffic moves at unreduced rates of speed. Safe distance between cars is maintained by automatic radio control. Curved sides assist the driver in keeping his car within the proper lane under all circumstances.
Does this sound kind of evolution or revolution? How new is this? Hey, 1939. Well, check out this one. 1954.
Roger, Firebird 2. Move to electronic control strip in center lane. Synchronize your speed and direction.
Check. I'll tune speed first.
Autopilot, that's not a new term.
Hold on, Firebird 2. You're now under automatic control. Hands off steering.
Nice music in the background, but wasn't he happy to take his hands off finally? And then, hey, a last one, but that's even more interesting. 1977.
Researchers at Ohio State University have been working on the project for 10 years, and they feel that cars like this one may be on the nation's roads by the year 2000.
A person wishing to drive from his home to another city would manually drive his vehicle, much as he does today, from his home to the entrance ramp of an automated expressway.
Research for the computer car is being funded by the federal government. Federal officials feel that computer driving could be safer and more economical than regular driving. Part of the mechanism which controls the driverless car is embedded right here in the concrete. This line regulates steering. The lines to the outside are for braking and for speed. The computer-operated car can move around this track at over 60 miles an hour. But in the broader sense, no one seems sure where the car is headed. Experts admit it will take huge amounts of money to embed the sensing devices in highways and lots of persuasion to convince motorists that this is the way to drive.
Well, anything new? Evolution or revolution? That seems to be apart from more of the embedded piece into the road. Those problems are not new, isn't it? But that I leave that to you for further thoughts. But it's always interesting to go back in history and see that trends come and go. And sometimes now we seem to be deeper into the trend. Hopefully, we're going to get there. And I'd like to thank Professor Steven Schladover from University of Berkeley, who actually landed those videos. According to him, and that was a talk that he gave probably about 4 years ago, and he's been working on all kinds of autonomous vehicle problems, including platooning, etc. And his claim was in 2075 would be the time when you would have like fully level 5 vehicles. But hopefully he's a little conservative. I just wanted here now to give you an idea of what AVIN does and what could it do for you if you're involved in R&D in the province of Ontario. So we actually run programs, funding programs to help basically drive R&D in the province, to drive economic development, job creation, wealth creation in the province, increase the tax base ultimately. And so we have basically 4 types of programs. So we have what we call the partnership funds, which include a Stream 1, Stream 2, and Winter Tech Development. And you can see there on the chart, we basically will provide up to $1 million on the Stream 2. which corresponds to 1/3 of the total project budget for your project. But you need to work with an industry partner that will help you commercialize your solution. Typically, in the automotive world, it would be a tier one, an OEM who could integrate the technology into their offering. We've got also another piece that's called a talent development, and talent development is really a subsidy to help you hire talent, often talent that comes with more advanced degrees, which are harder to fit into the industry sometimes, just simply because their thesis was on maybe more obscure subjects. So here we're really helping industry to make it easier for you to scale. And so if you have any questions on this in the future, please feel free to contact me. So I wanted also to give you an idea of what we've done. So the program, so AVIN, was launched in November 7, 2017. So we're basically now close to entering our 5th year. And there were $85 million that were allocated for the 5-year initiative. So far, we've supported 61 partnership fund projects. 24 to Stream 1, those are the $100,000 grants, and then 37 of the Stream 2 and Winter Tech. And so those, the first batch of those started in 2018. And we've also supported 146 different projects with talent development. Here next, what I wanted to give you is a flavor of some of the projects we have supported. So you'll see a few on electrification, but the reason we originally did electrification was not really so much about the EV side of things, but rather the clear situation that if you were to use an EV and be in a shuttle, take a ride, you wouldn't be expected to get out of your car and start to pump some electrons in it. So so this is why we supported a project with a company called Elite Power, used to be called Havilar, a spin-off from University of Toronto, and with Opus One, which is an electrification grid company, and with a Chinese automotive OEM called Chery Motors. Actually, there will be, in a few days from now, they will have their official basically demo day. So it started in 2018, and now we're getting to the end of this project. So they're basically equipping an e-van with a wireless charger unit that will be both, of course, in the vehicle as a kind of magnetic charging kind of unit, plus, of course, in the ground as well. So that's a good example of a project we supported with the fund. We've got another one here, a company called Cable Shop in WeTrack, and they've worked with another type of EV manufactured by a South Korean company called Daechang Motors. And their idea here was more about creating a connected vehicle solution. So the performance, the site, the location of the vehicle could be better monitored across the network on the roads. Again, that was a smaller project. That's another example. We work with a company called eCamion. So eCamion is well known for its charging stations. I think they've done a number of installations along Trans-Canada Highway. And here again, although it looks like it's an EV solution, the idea was, and the pictures doesn't give you a good example of it, but really their main piece here was to create a robotic arm that would automatically find a path and a location on the charging port of the vehicle. And so again, you could be in your vehicle, get on by a charging station, and the arm would just locate the charging port and connect to it. And we have a few other, here, another example here is Sensor Cortex. Sensor Cortex is a company in Ottawa. It is a spin-off of University of Ottawa by the serial entrepreneur called Robert Lagagnère. And basically here, that was a very good example where this company says, hey, we can put smarts into sensors. And we'll start with radar. So they partnered with a company called Valeo, which is a tier 1 supplier in the automotive industry, which already had a product line of radars. And so what basically Sensor Cortex did is to apply AI technique at the edge in order to make basically the sensor smarter. Another example here, and we're really crossing multiple territories in the sense that we say, hey, there's more to it than necessarily having a standard kind of sensor based on the vehicle to measure, detect people, detect obstacles. Here we've got an application where a company called CloudDX, Kitchener-Waterloo startup, which is known for its wearable, medically certified sensor, multi-sensor to basically to measure and monitor wellness of the bearer. And basically they started to work with Forcia, which is another French tier 1 company with its office in Michigan, to basically integrate that unit inside the cockpit and let it communicate with the user and with the seats, which Forcia actually makes. So then the idea was to have a multi-sensor detection of the status of a driver in the vehicle. We still have some here. Another example of us is Pantonium, where we were talking about shared multimodal transportation. Now, Pantonium, its claim to fame is really its on-demand transit. So they created a system, and it's a monitoring, a scheduling, AI-based intelligence system that allows basically a transit authority to be able to provide services on demand with a reasonable waiting time, and etc. So Pantonium these days has a number of clients, but they started their work with a demo in the town of Belleville. And so this way they've been able to show, especially over the last year and a half or so during the days of COVID, they've been able to show a number of really interesting kind of use cases of, instead of running buses empty on lines, then they've been able to show a good reduction in costs and an improvement in service for people at all hours of the day using their solution. I could go on for a while here, but here are a number of other projects we've done. So the eCamion I've discussed, the Havelar, now it's called eLeap. And QA Consultant was another company doing software testing on the ISO 26262 standard. Xmatic with the City of Toronto. So Xmatic had a system called a Lane Cruise Fleet Pilot. So it was indeed a combination of, it basically was an aftermarket L2, L3 kit using actuators to control the vehicle and as well as, of course, monitors to give it basically an L3 functionality. We've worked also with a company called Omron Automotive Technologies, which is a well-known tier 1 as well in the technology, and they work with George Shaker, University of Waterloo, on in-vehicle millimeter wave-based occupancy detector. Anyway, could go on here, and I think we're getting close to the end, but we've got a range also of other projects. So for instance, vehicle monitoring or prognostics with diesel environments. So Pretext, a company also from Hamilton, Envision AI, Thales Canada. So they're putting together a forward collision warning system on a locomotive. We're using video cameras, using multimodal, multi-sensor fusion and detection and control of train operations. Snowplow with Salter automated system with hydraulic controls, a company in Georgetown. Odzu, which is in the shared, maintains its own fleet of vehicles working with FAF motors. So they have also some kind of telematics device that can monitor the occupancy of the vehicle, monitor the state of the vehicle. And then a certain analytic solution will work with GM Canada on something similar to Pretech, where they can do an AI-based monitoring and prognostics on the vehicle's performance. I'm pleased here to announce that on March 24, the government of Ontario has topped up AVIN, and which now becomes OVIN, which will be launched in September of this year. So we've been topped up by $56.4 million to create OVIN, and OVIN will expand its scope to include now the last piece of the case, which is electrification. As you may know, 3 major OEMs have announced major investments in the electrification of vehicles in the province. And so we want, of course, to support the innovation around that.
Can you talk about the differences between, from what I hear, the middle mile and the last mile delivery and kind of self-driving segments, I guess you might want to call them?
My understanding is that the last mile tends to be the most complex one. The middle mile is that you basically have a point A and a point B that's generally fixed. So you can do then a level 4 type of implementation within a known environment, or almost 100% known. Of course, there can always be animals or other stuff, but the whole environment is understood. You could have an HD map that gives you a full understanding. So for instance, the Waymo service in Arizona, I believe, is considered a level 4 because, again, they have very fixed routes. Mm-hmm. And so that reduces the complexity of the problem. Well, if you go the last mile, then you'd have basically kind of a hub and spoke type system where you could go to all kinds of places. And even though the distances are shorter, it's now the environment is fully open. So that's where the complexity arises.
Mm-hmm. How do you determine viability of projects you support? For example, in the old videos of computer driving, the main issue was that making the road is expensive and not scalable. The project for wireless charging specifically had road altercations as the driving force of their solution. Could you elaborate slightly?
Well, it's a pretty open question in a sense, but we do at OCI, I mean, our business has been to fund innovation. So we're kind of a broker innovation economy, and we've been basically at this for over 30 years. So we've got first of all, an A to Z process inside our place. That's our business, basically, is to be able to assess opportunities, take those opportunities through the process of applications, formal due diligence, assessment, internal, external, and then to eventually a decision, and then funding, and then project management through. So basically a full life cycle of an opportunity. So a person like me and my colleagues, we work with the applicants. We have a fairly thorough process whereby we have a pretty detailed application form. We work closely. We kick the tires to a certain extent. And you can actually find most of this information on our website, where you can see templates of the application form we use. We're asking questions, direct questions. What's your viability? Can you finance a project like this? How will you finance it? So of course, money is important. We are looking at, although we know like autonomous vehicles is not going to happen tomorrow, but we're trying to ensure that the projects that we come in have a path to commercialization that's not in 10 years. So we're looking generally for applications or products, new products that have a relatively short term, 3 to 5 years. I mean, it always takes time in this business. It doesn't happen overnight. But and there could be multiple steps leading to the final application, and those steps can still be money making. And that generally, so we don't look pie in the sky type of projects, but we will look at applications that got a good path to commercialization with intermediate paths, which may allow them, of course, to either have revenues from sales, and which is often the case, raise funds, because we do try to come in at a point that's riskier, more speculative. We don't do 100%. We do 33%, but we call that a co-investment, and we call that basically it's a non-repayable, non-dilutive investment. So technically it's a grant, but we take it as an investment, and we want to see a return on investment. We have external reviewers, experts who help us determine whether this is a good opportunity or not.
On the topic of, so obviously all the buzz at the moment is self-driving cars. I'm curious, what else could we autonomize? I mean, planes, trains, what other kind of technology do you think there's opportunities for? Everything. We're
basically we're an MTO. We're sponsored by MTO, so we tend now to focus on roads and railroads, but we do have train project. A company like Thales, for instance, Thales, THALES, manufactures what they call a communication-based train control. So they're already part of the automation, not 100%, but the systems that we're supporting with them, for instance, will help automate fully. And guess what? Like the SkyTrain in Vancouver, that operates automatically. There's no drivers on that, and that's been ongoing for years. So there's a whole bunch. Like we can know a company called Ribbit. I'm not doing advertising for everyone, but that's a well-known one that's developing basically a kind of last 100 kilometers delivery for airplanes. So their airplane is fully automated. So that's another example. On boats or on water, then you could have, there's a company called ClearPath Robotics, for instance, or Auto. Auto is more into a manufacturing environment or a warehouse. Everything, and I mean, robotics can be applied everywhere. We're more focused at the moment on, like, another one is mining. That doesn't come across, but apparently mining is very electrified right now, and they're looking for ways to automate their vehicles. So the whole world is open to automation. It's just a matter of us. We have limited funds, so we got to concentrate on one sector, but the technology that we develop here is applicable everywhere.